All right, stat students, I know you're hopefully getting ready for your test today. It will be released at 1 o'clock. You'll need to turn the answers in at 3 o'clock, and please only turn in the answer sheet or answer document. You'll be given both the test document and the answer document. I just want the 1 page of answer document. So I want to talk to you through a few of these multiple choice questions on a previous test. First question is, which is not a valid alternative hypothesis? Remember, alternative hypothesis has to be not equals, less than, or greater than. One of those three. It can't be an equal statement of any kind. So just remember that. Complete the following sentence with the best phrase. A small p-value means. What does a small p-value mean? A small p-value means that if it's smaller than the significance level, then we're going to have convincing evidence that the alternative hypothesis is true. Just remember that small p-value or less than the significance level means that the alternative hypothesis is being supported. And then if a p-value is 0.2588, almost 26%, that means that sample is really likely under the null hypothesis. So this would be a fail to reject situation and not in support of the alternative hypothesis. So be careful about what you choose to state, okay? What's the main purpose of conducting a hypothesis test? It's to decide whether the observed experiment is due to chance. Does it just happen based on, well, we would expect this outcome? Or is it something that we wouldn't expect under the circumstances? So it's really to see if this would just happen by chance. And if it wouldn't happen by chance, that's when we have convincing evidence that supports the alternative hypothesis. Now, here's a problem where you're asked to find the test statistic. There is a formula for it, but we've always used the formula or the calculator. So it's a proportion test. How do I know it's a proportion test? Because the null is p is equal to, p is less than. So I know it's a proportion. So you're gonna go 1 prop z test, and you're gonna put 81 for x, 270 for n, and then you calculate, and it'll give you the test statistic and p-value, and so you'll just pick the right or correct answer that you get. Let's see. So then remember conditions. All the problems and samples I've given you have had conditions at the beginning. You have to always have a random sample. That's the always consistent criteria. The second thing is when you're dealing with a proportion, the successes and failures have to be more than 10 each. They both have to be more than 10. If it's not a proportion, if it's a z or a t, then we have 2 things that can satisfy the second condition. And one is sample size. If it's greater than 30, then we can do the hypothesis test. However, if the sample size is less than 30, but it comes from a population that's from a normal distribution, then we can do the test as well. So remember those. We do that in our tests. One thing I wanted to show here, we've seen this kind of a problem before, was open to us. Andrew claims to be an 80% free throw shooter. To prove his skills, he shoots 50 free throws and makes 35. Well, what we want to know is that something that we would expect, or would it happen by chance, or would this be unusual? And then tell us that maybe he isn't really an 80% free throw shooter. So if you look at this dot plot, this is 66%, 0.66, and this is 0.68, this is 0.7, and this is 0.72. So when he shoots 35, that means it would be somewhere right here. And if you count those dots, there's 7, 8, 13, so 13 out of 200 would tell us about 6.5%, 0.065. That's probably too big of a p-value for it to be ordinary or an everyday outcome. So the hypothesis test, state the hypotheses would be that p is equal to 0.8, and then p is less than 0.8 would be the two hypotheses. And then in the dot plot, the p-value would be estimated, as I said, 13 over 200, or about 0.065. And then interpret the p-value in this. Well, we would say that this sample would be expected as an outcome because it's more than 5%. And so therefore, it doesn't give us evidence that he doesn't shoot at a rate of 80%. And so that would be the conclusion there, and based on the p-value. Another question here, on the conditions of performing a test, are they met? Well, it's random. The question that we have is that we have only 10 students in the sample. So we have to see somewhere where it would indicate to us that this comes from a population that's normally distributed, and it doesn't say that anywhere. So remember, you always have two criteria. You have that it's random, and then the second one has two things that could satisfy it. One, if the sample size is big enough, 30 or more, and if that's not met, then you have to check, is it from a normal distribution? So you only need two, the random, and then one of the two second ones. So remember that, keep that in mind. And then we talked earlier in the chapter, long time ago, about type 1 and type 2 errors. I've eliminated that from the test. And then you're going to have a couple of hypothesis tests. There are only 10 questions, 6 of which are multiple choice, and then a couple of short answers, and then a hypothesis test. So that's just a brief review. Look at those things over, look at your hypothesis tests and significant tests that you did on the homework this week, and you should be in a good spot to be able to do very well on this test. All right, thank you, and have a nice weekend. No work tomorrow, and please, you're on the honor system. I'd like to see that you do your own work. So anyways, you're going to have about 2-hour window to do that. It should have more than enough time. It shouldn't take you 45 minutes to do this work. So anyways, thank you, and miss you guys, and look forward to the seniors. We may not ever get to see each other again, other than you coming back and visiting in the future. All right, thank you.